In order to measure the length, look, this is the cube, and you are going to measure this side. As a cube, the three sides, the height, the width, and the length are equal. Well, you measure only one. You can see that here this edge of the cube coincides with the 0. And then you say 1, 2, but it's something else. Every line is 0.1. Then you have to estimate the last digit. Look, you can say, for example, it's 5.0, 2.0, or 2.1, or 2.2. I don't know. It depends on what you read here. And the second digit is estimated. If it is sharp on a line, you say 0. But if it is between two lines, you say 5. Then you come here, you see the first number that you can read, and after that you count the lines until this edge, and then you measure the length given two decimals. Alright? And as you can see, the weight is given here in this scale. Then it's already given here. All what you have to do is to calculate the volume, and then having the volume and the mass here, you can calculate the density, and so on. For example, then you come here, according with the density that you calculate, you can compares with the results on this table, and you say the type of material that the cube is made of. And in the case of the liquid, well, first you see that the graduated cylinder empty weighs 2.0. And when you add 20.0 milliliters of the liquid, you see the weight. But all this weight is not because of the liquid. It's because also of the empty graduated cylinder. Then you have to calculate the volume of the liquid, and you can see the difference. The volume of the liquid is 20.0 milliliters. Then you have to calculate the weight of the liquid. And here you have in the other case, let me go here, let me put this bigger, okay, and let me see, in this case, we are going to see the density of this solid, but how are you going to determine the volume of the solid? By water displacement. You have here a volume of 20.0 milliliters of liquid here, and you have the weight. When you add the solid, you have that the level of the liquid increases 25.2. But is this the volume of the solid? No, because you have here first the volume of the liquid. Then in order to get the volume of the solid, you have to subtract. And the same thing with the mass. You have here the mass or the weight of the cylinder plus the water plus the empty graduated cylinder. Then if you subtract this to this, you will get the mass or the weight of the cylinder. And then applying the formula, you know, is mass over volume, and you get the density. And always you have a table to compare the results. Okay? Well, I hope that now you understand, but as you can see, everything is explained here. Everything is explained here.